channel. In this video, I want to take us through how we can solve problems on angles of elevation and depression. Before we go into that, I would like to say that if you're watching this video, please subscribe to the channel if you are new to this video. If you are a returning subscriber, I want to thank you for coming back to this video. I believe you will learn some things from what we have to share right away. Looking at angles of elevation and depression, the best way to explain elevation is to think of if you have, let's say, a vertical height of this nature. This vertical height could be a building. This is the top of the building. It could be a flag post. It could be a building. It could be a vertical pole. If a man stands at this point, let's say this is a man here. This man stands at this point. This is the eyesight of the man. If this man's eyesight is at this horizontal plane here, this is the horizontal plane of his eyesight, and this man decides to view the top of this building, the angle that he creates while trying to view the top of this building, if we call that angle theta 1, that is his angle of elevation. The distance between this man and the building is just what you have here. Okay? This man is standing here. He views the top of this building. While viewing the top of this building, his eyesight with the horizontal created an angle. The eyesight with the horizontal created an angle. That angle, theta 1. The angle theta 1 is the angle of elevation. That is his angle of elevation. Secondly, this is his angle of elevation. Now, if this same man stands, if this is the man here, is on top of a building, let's say this is the building height, this man is standing on top of this building, and he views a boat that is on the sea here. This is the sea. He views a boat at this point. This is the boat here. From the top of a building, he views a boat here. That boat is having the same horizontal plane with the top of the building, with the foot of this building. If this man, this is his eyesight, and the horizontal to his eyesight can be likened to this line drawn here. While viewing this boat, he looks at this boat from the top of that building. He looks at this boat from the top of that building. The angle that he creates here with the horizontal of his eyesight, which I'll call theta 2, is his angle of depression. So I can now say that theta 2 here is the angle of depression. This is his angle of depression. So we can say in a nutshell that the angle of elevation is the angle created when one takes his eyesight above his horizontal plane to view an object at a distance or at a height. View an object at a height. Once your eyesight is above the horizontal plane to view an object at the top of a building or at a height, the angle created between the eyesight that is raised and the horizontal plane is the angle of elevation. On the other hand, if this person views an object below at the sea, let's say he views an object at the floor or below the ground here, at the ground level here, not below the ground, but at the ground level here, the angle he forms with the horizontal trying to view this object at the ground level is his angle of depression. Now, how do we really apply these things in real life situations? There are several ways you can apply them. Let's say in a school compound where you have a flag post, a student can be standing and he sees a bird. A bird is standing at the top of the flag post. And when he views the bird at the top of the flag post, he creates an angle with the horizontal, which is his angle of elevation. We'll take a question to buttress our angle of elevation and depression. Just to buttress how we can solve problems of this nature. The angle of depression of a point P on the ground from the top T of a building is 23.6 degrees. If the distance from P to the foot of the building is 50 meters, calculate correct to the nearest meter the height of the building. Now, this question is a question on angle of depression. We are told that the angle of depression of a point P on the ground. P is on the ground. The point P here is on the ground. P is on the ground here. Let's call this is point P. Now, the building is here. The top, this is the building, okay? And then there's a distance between this building and the ground. This is the top of the building. All right? The top of the building is the top T of the building. The angle of depression of a point P on the ground, point P is on the ground, from the top T, from this top T, that means the horizontal level of this top T is here, okay? And it forms an angle of depression with a point P on the ground. Forms an angle of depression. Let's say this cuts out our angle of depression. This is the angle of depression. That angle of depression is 23.6 degrees. Then we are told again that the distance, if the distance from P to the foot of the building, the distance from point P to the foot of the building, this is the foot of the building, the distance of point P to the foot of the building is 50 meters. This is 50 meters. We are asked to calculate correct to the nearest meter the height of the building. We are asked to calculate this height, which I'll call H of this building. This is the building. This is the building. We are calculating the height of this building. Now, to answer this question, one of the things we need to establish is that, which we should know very well, is that the angle here, this angle formed here, you can see this line is parallel to this line. The angle here is alternate to this angle. So this is 23.6 degrees. This angle is alternate to this angle. If this is the top of the building and T forms an angle with P as the angle of depression, it means that the angle of elevation of P from the top T is this. That is why we often say that angle of depression and elevation are alternate angles, and these alternate angles are equal. So let's go ahead to find the height of this building. Recalling our knowledge of trig ratios has been put in an acronym of this nature, or call it SOHCAHTOA. SOHCAHTOA. If you can recall this acronym here, S is sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now let's look at the diagram and see which of them to use. This triangle here, it is a right angle triangle. This is 90 degrees, which tells us we are dealing with a right angle triangle. The side facing the right angle is the hypotenuse. This is the hypotenuse. The side facing the defined angle is the opposite. Then here is the adjacent. Since we have this as the side facing the angle, this is opposite, which you are looking for, over adjacent. That's tan, which is opposite over adjacent. So coming here, we have that tan 23.6 degrees is equal to the height of the building over 50 meters. Now from here, if you make this over 1, you cross multiply. H times 1 here is H equals 50 times this will give us 50 times 23.6 degrees. We go ahead to find the value of tan. So getting the value of tan 23.6 degrees, this will be 50 times 0.42 369. That is the value 23.6 degrees. And if you work this out, you work that out, it will give us 21.845. But the question says we should calculate correct to the nearest meter, the height of the building. Now, to the nearest meter, the height of the building to the nearest meter, this is 21 meter here. But if we look at after this decimal point, we have 8 here. 8 is bigger than 5, so we'll round it up as 1. That will become, it is now approximately 22 meters to the nearest meter. To the nearest meter. And that is the solution to the question we are asked to calculate.